Hey guys, it's Ashley Rice here, and welcome to another video. And today we're learning about the chain rule. In calculus, the chain rule is extremely important, and if you're planning to become a STEM major or just learn calculus in general, this is a very important subject as it is a key part of derivatives. Let's start with what is the chain rule. The chain rule is used in calculus to find the derivative of composite functions. And if you don't know what a composite function is, it's basically, I'll show you right here, it's f of this circle of g, and that's basically what it is. And this basically equals f of g of x. And when we take the derivative of this, we're going to get the base formula of f prime of g of x times the derivative of the inside, which is g prime of x. So in other words, it's taking the derivative of the outside function. So basically it's taking the derivative of the outer function evaluated at the inner function multiplied by the derivative of the inner function. Let's break it down. Some common examples would be e to the x squared log of 3x squared, or cosine of x squared. And just taking the derivative of all of these apply to the chain rule and its use. Let's start with a simple example like taking the derivative of sine of x squared. So how would we even approach this problem? So when we think about chain rules, we usually want to think of layers. So to give you guys a better understanding of what these layers are, let's take a random trig function like sine of x and make that x equal to sine again. So we have sine of x, and hopefully you see it here about these functions inside of another function becoming layers. And that's basically why we need to use the chain rule. So when approaching a problem, we first want to define what the outer function is and the inner function is. So the outer function in this case would be what's the overarching function affecting the variable at this time. And where I like to think about it as substituting a variable into the expression we have. So suppose sine of x squared, we can basically say sine of u, where u equals x squared. We see that this sine of u is basically becoming this overarching function, and that's basically what it is. Yeah, that's our outer function. And now we have to deal with the inner functions, where our inner function should be what this u is. So in this case, our inner function is x squared. Let's move on to the equation we had before, which was finding the derivative of the outer function evaluated at g of x times this inner function g of x, the derivative of the inner function g of x. Our outer function is basically the f, and our inner function is basically the g. So what is the derivative of f, which is sine of u, which is cosine of u? And our u is g of x in this case, so we would say cosine of x squared. And then finally we have times g prime of x, where g is x squared, and the derivative of g prime of x, is going to be 2x. And this is our answer. We could probably just say 2x cosine x squared, and we solve the problem. Unfortunately, this is probably the most simple example you're going to see when dealing with the chain rule. But let's move on to a harder problem so this actually grabs into your mind. Also, I'll have some practice problems linked in the description below so you can actually practice this, because I promise you doing some practice problems is going to make you perfect at the chain rule. Let's move on to this hard example of taking the derivative of e to the power of tangent of x squared plus 1. If you're a person unexperienced with the chain rule, you would not even know how to approach this problem whatsoever. And to be fair, if I didn't know, I wouldn't even know how to approach it either. But good thing we have the chain rule to solve all our problems. When I started the video off earlier, I had e to the x squared as an example. And why can we take the derivative of e to the x squared and say we use chain rule for that? It's because we treat the outside and inner functions of an exponential as e to the u. This u is going to be x squared, and the exponent in this case is our inner function, while the e to the exponent is going to be our outer function. So let's use that to our advantage. So here I listed the out and in respectively for outer and inner functions. So going back to this e of u I have right here, let's see, what is this u? It's probably clear, but it's tangent of x squared plus 1. So let's write that down. So you'd probably think we'd solve this problem using our formula we had before. You would be correct, but there's more to it with the formula. This basic formula is only for these basic problems, but this formula can be expanded infinitely. Just like going back to this sine of sine of sine, it's kind of like that, but we need an equation for this example because we could probably take the chain rule of tangent of x squared plus 1. So we see this tangent of x squared plus 1, and we can put this x squared plus 1 as equivalent to u, and so we have to use the chain rule again. So I'm going to rewrite the equation like this. So hopefully you see what's happening here is we basically use the chain rule layer by layer, and just by using this method we solve any chain rule problem. So let's list this as second inner function, as this h of x is x squared plus 1, and change this tangent to tan of v, and this v is equivalent to x squared plus 1. Now we just plug it into this formula right here. It's basically extending the basic formula we had before, and you apply this formula to any time you're using the chain rule. So we get e to the u, which is tangent x squared plus 1 times tangent of v, and v is x squared plus 1, so times h prime of x, and h prime of x is basically the derivative of our second inner function, and the derivative of x squared plus 1 is 2x. And this right here is our answer. We don't have to do anything else besides simplifying this, if you can even simplify it. And this is an example of a hard problem or question you're gonna see on practice problems or on the AP exam. Before I end off this video, I wanna give you guys some tips I think would very much help you out with the chain rule. This first tip is always trying to identify what the inner and outer functions are dealing with the chain rule. And I always ask what is the last thing affected to the x value as a whole. And hopefully that helps you, but it might not, which comes to a second tip, where you want to always use substitution, like how I used in this video, where I set u equal to the inside functions, v equal to the second inside function, and using parentheses to make it more clear. That might not work for you, but if it does, hooray. If it doesn't, just grind out practice problems. I'm sure you're going to find out your own way. There's not one way to solve any problem. Another tip is going to be always be organized when you're applying the chain rule, because suppose your calc teacher gives you an evil exam because your calc teacher is evil and tells you to find, using the chain rule, the 10th inner function or whatever. And if you keep on doing the layers and layers and putting them somewhere random on the paper, you're gonna eventually mess up and your teacher's gonna give you an F. Realistically, that's not what's gonna happen, but if that helps you, it helps you. And you have your own way of solving the problem. Thank you guys for watching this video. I really do appreciate it. And if you do like this content, you can choose to subscribe and like and whatever. But more importantly, do your practice problems, and I will link some in the description for you to do. And also, if you have any other future video ideas I can make, just leave them in the comments. I'll definitely look at it and see if I have the ability to do them. But other than that, see you guys next time.